slide. Okay, cool. Yep, starting. All right, cool. Here we go. So, the next type of problems that we have.
Wait, is this the different objective?
Yeah, you can call it rationalizing the denominator. Still the same thing.
But it's the third one?
It's still rationalizing the denominator, but it's just a very different case because now it's a binomial. It doesn't have just one term. It's not a monomial. It's a binomial. Ay, ay, ay. Yeah, you're like, ay, ay, ay. That's my life. Same. All right, cool. So, we're still going to use the identity property, so it's still going to be some version of 1, except we're also going to leverage another idea, and that's the nice thing about 1, right? We can define anything over itself, but what we're going to do to kind of fix this problem is that we're going to use the conjugate of the denominator. You guys know the conjugate, what that looks like? If you don't, it's going to look exactly like the denominator, except instead of having a plus, it would be a minus. Okay, can you guys think of the benefits of that right there? We know that all the middle goes away, right? Which means that we're going to get the first one squared and the second one squared. So all I'm really going to get here, and I'm just doing the denominator for now, this is simply going to become 2 minus 13, which happens to be negative 11. And now my denominator is rationalized. Okay? The hard part becomes the numerator. Did everybody see that? Questions on what I did?
Do you have to subtract the top one?
What?
Do you have to put subtraction on top as well?
Yes. Yes, because this is the fraction we're choosing to be 1. So yeah, this also has to be the square root of 2 minus the square root of 13. Otherwise, I've changed the problem, and it's no longer what I started with.
So Munoz, what makes the square roots cancel?
Well, here's what's happening, is if I multiply this times this, it's really becomes square root of 4, doesn't it?
Okay.
And we know what the square root of 4 is. What is the square root of 4? It's just 2, so I'm kind of skipping that.
169 and 13.
And this would become the square root of 169,
13.
which is just 13.
Got it.
Okay, that's a step I kind of skipped there, I'm sorry. Thought you guys would see it. You guys see that? From here it actually goes to there, and then it really goes back to here.
Break apart.
Almost juicy.
Oh my gosh.
Juicy.
Now multiply 7 then.
Hold on, so 13 becomes 4.
Munoz. Put 7 in.
You mean the numerator?
Yeah.
When we look at the numerator, you're just using your distributive property. Because this is a quantity, then you're just going to go 7 times radical 2 minus 7 times radical 13. And that is it. There's not much more you can do. Right, Avari? I understand. You tired? We all tired. You tired? They're tired. We're all tired. We're tired.
Douglas
I'm
kills you.
tired,
We're all
you're
tired.
tired, we,
Tired.
she, he.
Douglas kills you, man.
What?
I said Douglas kills you.
I don't have Miss Douglas.
Oh, well, we do.
Man, her class is so easy.
What? I'm gonna throw a brick at you.
Just both of you at the same exact time, you see that?
That was beautiful.
Me too, I was like,
I love it. It's
no, but they
recorded
both
too.
just stood up at like the same time with the same exact head movement. That was funny.
You guys almost got whiplash.
I know.
You're like,
I'm gonna throw a brick at you.
We're gonna go break the
hey, maybe he's a language guy, okay?
Linguist?
No.
Maybe he's a
I'm a
linguist.
language person. I pass all my language
Language.
classes and I hate
Myrtle
it.
doesn't even
I
have
never
one.
hate my English class until
Oh.
this year.
No, he doesn't. He has Miss Castellan with me.
Oh. What's her name?
Miss Castellan.
Really?
Casa what?
Castellan.
Castellon?
Castellan.
Castellon?
You know, like a lawn? Like
Castellan.
Castellon?
Castellan, yeah.
Casting her off, or casting a lawn.
Whatever you want to call her. Miss.
I got
just
to
did it to piss off.
I don't know who that is.
She's like,
Likes the Broncos.
yeah.
Okay, that helps.
She's like,
I like chocolate. That doesn't help. Describe Mr. Munoz.
He likes math.
That would help. Alright, so
she likes English.
enough of Douglas and Castellan. Or Castellan.
There you go, you should have
Castellan.
You're gonna make her mad, right?
Cast
You can
all
call her Duncan.
Aren't you?
Duncan, Miss
Are you
Duncan.
recording
Okay.
too?
I think I know who that is.
There you go.
No, I don't.
I was like,
You're right. I'm sorry.
I think it's funny that you're putting
Yes, I
this
do.
all
No, I
into
don't.
your,
So, looking at the fraction, what's the new one I'm gonna multiply by?
Radical
2
2 plus
plus
radical
7.
That's radical.
Yeah, so it's gonna be, I'm gonna multiply by radical 2 plus radical 7, numerator and denominator. Now, do you see why it becomes more difficult in the top? Because here, I can already see all that's gonna happen is 2 minus 7, which is
-5.
negative 5. Okay, now, anybody need to see those steps?
Yes.
Or is there, okay, so let me do that. So, I can multiply those two, because this is conjugates, right? So that becomes the square root of 4 minus the square root of 49. Well, the square root of 4 is 2, and the square root of 49 is 7, so that becomes negative pizza. Okay.
Then you're gonna do the top as well, right?
Now we gotta do the numerator. So I'm gonna do it, I'm gonna bring that negative 5 to here. Is that cool?
That's right.
I'll show you why.
So you take
Dang it.
3 times 2.
So, what I have here is literally two binomials, because they're kind of together, aren't they? So I'm going to have to start with this guy. So that's going to give me the square root of 6. This will give me the square root of 21. Looking at the other part of this first binomial, I'm going to get a radical 10. And then finally a radical 30. Okay?
Don't copy. 35.
I'm not even talking.
Oh, JK.
JK.
Smiley face, LOL. Good looking now, thank you. You guys are awesome. That's it, you can't do anything else. You can't simplify them, you can't combine them because they're not like terms. There's no common factors. Obviously, because what we used were all prime numbers up there, see?
Yes.
So no, it's not going to happen. Man.
Wait, so are you suggesting that every time you multiply two prime numbers, you get a prime number?
No, you'll get a composite number, but their prime factorization, you'll get two separate primes.
Oh, I see.
Right, like if I took 2 times 2, then I can see, oh, obviously I had two 2's involved in this.
Right.
But these were all different primes.
That's true.
It's 2, 3. Actually, the first 4 primes, except for 1. Is 1 prime? Is 1 prime?
Yes.
No.
1 time 1 equals
No.
They kicked them out.
No, because it's 1 times 1. It's not 1 times the number, it's 1 times 1.
Well, it's 1
Right?
times itself technically,
Yeah, exactly.
1 times 1 equals
which is 1 and that number.
Well, yeah, but
But if we
It's
left it in,
technical
we
now.
break the math.
What the heck with it? I thought it was prime.
No, it's not.
I never had it.
one is
It used
taking
to
math
be,
and going,
but they changed it. And that's not sarcasm.
they?
that's not
Me, the world of math.
Isaac.
All mathematicians unite and decide. We
Is
can't
there like a big
have.
convention or something for this?
Yeah.
There is?
If I say any more, I'd have to kill you.
Do it.
With math, of course.
How do you all speak the same language?
Death by conjugation. That'd be horrible. Alright, moving on.
The imaginaries.
K cannot equal Z?
Ew, that looks nasty. Okay.
Gabby.
I don't want to do
No, don't get, it's not, look, let me just say this real quick. There's some conditions under here. Let me tell you why they're there. K cannot equal Z because if they did, then it just would be 2K, right? 2 radical K? Or 2 square root of Z. So that's why that rule is there. The other reason why this is there is because if I said that these were 0, then that'd be 0 plus 0. And what's 2 divided by 0?
0.
No imaginary.
Undefined.
Undefined. No.
You can do it.
No, not null. Undefined. There's a difference between null and a defined.
What's the difference?
Math. With undefined, we really can't decide. There's actually going to be a couple different things that you can say for that solution, but it's not one. There's not one solution, so it's undefined. We can't tell you what it is.
With null, it doesn't
With null, that
exist.
means there's nothing there. There's zero solution. But in fact, there really are many, 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 many. But we just can't decide on one. Therefore, we say undefined. And maybe one day you'll fix that.
One day.
Moving on. We good?
So now we're gonna do K minus.
So in this case, yeah, what we're going to do here is just go root k minus the square root of z, which is going to give me simply k minus z, and then on the top I'm going to get 2k. That's not a 2. Sorry, jk. Oh, I got a k though, not a j.
Oh my god.
2 radical k minus 2 radical z.
Z.
Right, guys?
Your math name should be K minus. Sounds like a weird rapper name.
Like TI-84.
Like K minus.
Oh my god.
You know, there's a rap song out there, right? It's What You Know About Man, and the rap guys, he used TI-84.
Stupid.
That's funny. That's TI-84 right there, calculator. But the guy who made it was TI.
Yeah, the guy who made that, the original song was T.I., and they switched T.I.'s version to the math version.
And the rapper's name was TI-84. I would call you Natural Log, because you're thin and slim.
Oh my god.
Like a log.
Look at calculators.
Thanks, man. You guys made me feel better about myself.
That's your math rap name.
Natural log.
Natural Log.
I-
Just call me Ellen.
It sounds like
Because that's the
you're calling him
abbreviation! Oh!
lazy. It honestly sounds like you're calling him naturally lazy. You know, because when somebody calls you a log, it means
You
you're
log.
lazy.
Oh, I didn't know that.
Yeah, that's what
I've never called anybody a log.
You called him a
That's what that
natural log.
Yeah, that's math though.
Yeah, but that's also a log.
I wasn't the one who made the joke.
That's radical. Shut up.
Sorry.
I'm sending bad vibes your way.
Sorry.
Okay, so we've got this here fraction, and we want to simplify it. Okay, but when I look at it, my head hurts sometimes. Yeah, it's like, why for you know? Just tell me what you want. And what it wants you to do is to simplify. Okay, so I want you to first understand what this is saying. What is happening here is really two fractions that have the same denominator, and they just put them together. So let me tell you what I mean. If I had, let's go with 3/7 plus 2/7, doesn't that equal 3 plus 2/7, aka 5/7?
Yes.
Does everyone agree with that? With that fraction math over there?
I do.
So what we're looking at here is this version of it. And the reason why they didn't go ahead and say, oh, 3 plus 2 is 5 is because those are not like terms. Does that make sense?
Yes.
Yeah.
Oh.
Yeah, man.
All right, cool. So I could simplify each fraction individually, correct? But I could also simply simplify it this way. So what I'm doing is I'm saying, oh, all three of these numbers can be divided by how much? 4. So if I divide all of them by 4, I'm going to get 6 minus
9. Square root of z.
9 radical 7
Yeah.
over 4.
Yeah.
Done.
Wait, what?
Really, that was it?
Now, personally, well, let me say this. That's what the slide is going to say. Personally, I would take it further.
Also,
And I'll tell you why. These two are still even, aren't they?
Yeah.
So at this point, I would break this fraction up and say that that is 3/2 minus 9 radical 7/4. Because that is in simplest terms.
so would they take both of them, or which?
I don't know what they'll do in the power school. Sorry, in the program yet.
In the power school.
In the power school, it's not the power school. It's the math lab. Sorry. I'm telling you, the slide is saying this is the answer, but I would say this is much more lowest terms. That is truly the lowest terms.
Okay, so The answer most likely in math lab would be the first one.
Well, I want you to try it. Well, maybe I'll try it when we do it, okay?
Okay.
I'll try it and then we can, if it doesn't, then we'll put that in there.
Okay.
But that's it. Math, yeah?
Yeah.
That's different. Or is that the one you were wearing last week too that I said made me happy? No, it's different, huh? It's got all the hot colors. I like that. Moving on. So here, we want to simplify this quotient.
Divide by 2.
Before I even do anything though, I want to make sure this radical is in simplest terms first. So that I'm going to come over here and take that 32,
Upside down cake.
go 2, 16, yeah, 2, 8, 2, 4, 2, 2, right?
And then you come out with 4.
2x plus
So we've got 2x plus
4x
4x
radical 2.
radical 2 over 6x. Okay?
Now we reduce.
Someone's going to ask a question here.
See, I just don't understand.
Did you just want a question?
No, someone's going to ask a question. I was being psychic here. What happened?
He doesn't understand.
Okay, you see how this didn't change? That's still the same, right? This is what changed. So,
I got one.
here's the prime factorization of 32. I got a pair of 2's there, don't I? That means they get to come out? One of each. So how much is 2 times 2? Okay. And then how many do I need? You said pairs, right? Wasn't that a pair of x's right there? So that gets to come out. And what's left inside? Well, the only thing that was left was that 2. That we didn't have a partner for. We didn't have a little twinsy. But now we can simplify because I can see that all these are divisible by 2 and x. So this is going to become 1. This will become 2 radical 2.
No, that doesn't become 1, that becomes x. Liar.
No.
3. Boom. Done. Yeah.
What's x over x, dear? You see the x?
What about the other x?
Same thing. Remember, it's 2 fractions with the same denominator. We're choosing to kind of put them together. So if you want to separate it to see it better, you can. But we're just kind of simplifying to both of those as if it comes twice. Then separate it. Then separate it. It's going to help. It really will watch. Because here's what you're going to look at. You're going to look at 2x over 6x plus 4 x radical 2 over 6x.
It's such a fancy word.
It's not. It was a 2 originally. Okay? So when you break it up, that's what you'll see. So this becomes 1 over 3, right? This becomes 2 radical 2 over 3. Oh, same denominator? Back to that.
Oh, okay.
Okay?
That's it?
Yeah, that was actually 3 different ways. Questions here?
No. That's the 2 photo words.
Say something.
Ungiven.
No, don't give up on this. It's okay. We understand. That's okay.
Anything I would have taught to you. Oh.
Buenos. Buenos. You're done? Is that it?
No, that was math.
No, that was.
I don't teach it.
Bye. See ya. That was math. That was all of the
That
math.
was it?
All of the Bye. Have a good time.